produce repetitive patterns that are characterized by what information theorists call redundancy. And repeating the same symbol string over and over and over again is not a good way to build the complex irregular sequences that are necessary to build actual proteins. So if you have the same symbol string repeated over and over again, you get a mantra, not a message. And laws, by definition, capture repetitive patterns of order, but they do not, and therefore, I think, do not explain the origin of the kind of what we call specified complexity information, the digital code in cells.
But there are mechanisms by natural law in which you can have gradients of matter and energy being tapped to produce structure and information.
You have asked us a couple questions. Do you all have an explanation for the information that's necessary for the origin of life?
I think this is something that is an area of active research among origin of life researchers as to ways in which that information could emerge. There's also people doing mathematical modeling of this. It's an area, as Michael said, it's premature.
Would you point to a model that you think is successful? I mean, is there a naturalistic explanation for the origin of information?
I think that what we try to do in biology is go as far as we can with what we understand about nature, rather than bringing in forces or intelligence outside of nature.
Well, we would welcome that. First of all, we think for example, much of the work that's been done on the origin of life, the simulation experiments, the ribozyme engineering, actually ends up inadvertently underscoring our point, which is that you need intelligence to move these chemical processes in a life-friendly direction. There's always this investigator interference. In RNA world experiments, they're also termed ribozyme engineering. We think that's highly significant. The engineers are playing the role in overcoming the sequencing problem.
Could I make a comment?
Yeah, go ahead.
Sorry. I agree with you, Professor Weber, that science should go as far as it can in trying to explain, things like the origin of life and so on by without invoking intelligence. But I think it has. And I think it's reached its limit. And I think there's good reason to think that not only the origin of life, but origin of these complex, elegant systems is not explainable by undirected natural laws. And if somebody else doesn't think so, a question I'd like to know is when would you think so?
I think that you're getting out of the realm of science into the realm of philosophy.
But you said science should go as far as it can. So the question arises,
and beyond that, at this point in time, we can't.
But how do you know when you're
scientific
there?
speculation? We can have philosophical speculation.
But I'd like to point out again, there's more rule setting going on here. Science, essentially, Professor Weber is saying, must limit itself to materialistic explanations, and he's unwilling to stipulate when science would ever abandon that rule. There was another rule that was important in the formulation of the historical sciences in the 19th century, which was that we should explain things by reference to known cause and effect processes. And that's the rule that we're following. It's the rule that sometimes is termed uniformitarianism, that our present knowledge of cause and effect should guide our inferences about the past. What we know from our uniform and repeated experience in the present is that only intelligence produces digital code. So the presence of digital code in DNA, we think, is a strong indicator of a prior designing intelligence, and we think that's based entirely on a standard canon of scientific method. Professor Weber is saying, well, we can't consider that possibility because the rules of science don't allow us. At that point, I say what Mike once said in one of his talks, let's break some rules.
I have a question that directly applies to that, and then I want to bring Craig in, who's been sitting here very patiently. You made a reference, it might have been a slip of the tongue, but you said something about leaving behind materialistic explanations. And there's a phrase that's used among philosophers that is methodological naturalism. That is that the explanations given by scientists are restricted to natural processes, the properties of matter. And to go outside of that limit is to invoke something non-material. Plumbers rely upon methodological naturalism when they fix your plumbing, for example. they rely upon natural means to try to solve the problem. Now, if we start thinking about abandoning that restriction and letting explanations go outside the natural domain, I wonder how far that's going to go. I wonder if you'd be willing to say that within, say, law or medicine, when decisions are being made about guilt or innocence or about the source of a disease, that in those contexts you'd want to abandon methodological naturalism as well.
I think what Jim is arguing is we don't want science to appeal to magic. And indeed, we don't want science to appeal to magic. But look what's happening right now. We're having a conversation back and forth between Jim Hoffman, philosopher, and Paul Nelson, philosopher. Agents. We are real causes. Here I am talking to you, talking to Jim. He's responding. No natural law, no physical process, no algorithm can possibly explain what we're doing. To explain this event right now, this exchange, you need to refer to a person, a unique agent over there and one over here and all of you. That's real. It's not spooky. It's not magic, but it's not reducible to strictly physical laws or processes. The causal category of agency is something that we use all the time in explaining. And in fact, in law and medicine, agency is directly relevant to assessing guilt or innocence. There are no appeals to magic, but if someone's convicted of a crime, it's because they did it, not a physical law, not a regularity of chemistry. So I think the causal category of agency, intelligence, is what we're appealing to. It's not spooky, but it's not strictly material either.
Yeah, but the other thing about that is that in these discussions, usually it's not simply agency, it's direct causality. In other words, the agent has to interact with the physical world in some way. And if that's what we're going to give up, well, then you open the way to basically to miracles.
How would you categorize the Big Bang? When it was first proposed, as I think somebody mentioned, maybe it was me, a lot of I'm getting older. A lot of scientists really were very upset with it. And as a matter of fact, in the late 1980s, there was a peculiar editorial in the journal Nature by the editor John Mannix entitled "Down with the Big Bang," which he said was philosophically unacceptable, quote unquote, and it because it gave aid and comfort to, quote, creationists, unquote. Now, there was something that, what natural cause created the universe? Certainly nobody at the time knew, and people thought it was pointing towards a theological event, and yet nonetheless, we now accept it as science. I tend to see ID in pretty similar terms, that, maybe it does point outside nature, but heck, look at these patterns. It's like the pattern of seeing galaxies rushing away from each other. These patterns are things that fit into a category that we know about, intelligent agency. So if the Big Bang can be considered scientific, why not intelligent design?
Yeah, it takes time, and you and I both come from the Catholic tradition, so we have a sense of patience, right? A couple hundred years goes by, and hey, we'll get it right. So I still stand, on my same point that the Big Bang controversy was resolved by scientists who worked in that field, and this one will get resolved also by scientists.
Okay, can I just make a point that you're then not ruling out intelligent design a priori? You're simply saying that you are going to be skeptical until more scientists join.
Yeah, I think trying to draw a line between what is scientific and what is not very useful. The question is, what is fruitful for future research? But the kind of points that Bruce was making, there's a research program, where is it going, where is it leading? I think that's a more interesting question than trying to figure out what's scientific and what is not.
Let me interject here, sorry.
Can we get our last question in with Craig, because he's been sitting here all this time. Just